Hello and welcome to Research Matters podcast. Today I, Aishwarya Vishwamitra, will give you a summary of science stories that were published during the week on Research Matters. In your weekly dose of Indian science news today, I cover stories on space and ecology. In a galaxy far, far away, just kidding, right here in our solar system, a space probe called New Horizons, launched by NASA in 2006, conducted the first mission to Pluto. Years later, it encountered 2014 MU69, the farthest object in the solar system ever to be visited by a spacecraft. That object now has a fancier name, Aerocart, meaning sky in a Native American language. Found in the Kuiper Belt beyond the orbit of Neptune, we now know a whole lot more about it thanks to 3 new studies. But why is this important? Though we know when the solar system was formed, we don't know much about it in its early age, back when massive planets were being formed. The Kuiper Belt objects like Aerocart date back to that period and provide valuable information on how planets are formed in the solar system, because they preserve their structure for billions of years. Did planets form because small objects came together to form larger objects? Or did they form when clouds of gas and dust around the sun collapsed into a thin disk, radiated out its heat, and then left solid structures? Apart from being able to reconstruct a 3-dimensional view of Aerocart, New Horizons has discovered that Aerocart came together slowly with materials from a small part of a collapsing cloud of particles. Now, scientists know that the cloud collapse theory is the more plausible one. The fact that Aerocart is so archaic can help us piece together the role of planetesimals in the early solar system. Old really is gold. Closer to home, swirling clouds of dust have precipitated in their own unique ways. A study from Ohio State University, USA, has found evidence of toxic elements from Britain's Industrial Revolution all the way up in our Himalayan glaciers. Ashes and fly ash from burning coal and plants contain high concentrations of trace metals, which are released into the atmosphere. Atmospheric currents and wind patterns were responsible for bringing these metals to the snow-covered Himalayas. Massive deforestation and biomass burning in parts of the northern hemisphere have added to it since then. This does not isolate the problem to the Himalayas. Glaciers are melting at an increasing rate, which leads to the release of these toxic elements into the environment through glacial streams. As of today, the concentration of trace metals are too low to cause any danger. However, over time these metals could accumulate. Paleoclimatic studies like this one that decipher the climate and atmospheric composition of the past allow us to better understand the current climate and pollution dynamics and to predict the changes in the future. Speaking of water issues, an international team of researchers has found that large dams have heavily fragmented fish populations across the world. More bad news? India has one of the most fragmented fish habitats in the world. Dams and barrages affect the migration pattern by disrupting fish that migrate between fresh and salt waters, and disrupt freshwater fish that migrate between upstream and downstream. Overfishing, pollution, and the introduction of invasive species simply add to the problem. How do we combat this? Dams are useful to us. Electricity, irrigation, and drinking water depend on them. A promising alternative could be undammed tributaries. As they bring freshwater nutrients into the main river, they can act as alternative routes so that the fish can still migrate up and downstream. An ecological assessment of the habitat before the dams are built are crucial so that we can strike a balance between nature and man's needs. A few weeks ago, we looked at how the Pradhan Mantri Ujjwala Yojana scheme was more talk than action. Today we look at another such example. In 2019, the Prime Minister announced that the tiger population had doubled in the last 4 years. Sounds amazing, right? However, a recent study indicated that the tiger population survey deviated from the truth. It explains that these large numbers are largely exaggerated in comparison to actual findings in scientific research. The source sink theory explains that a conducive habitat acts as a source and produces a large number of carnivores, which may move out to surrounding not so desirable habitats or sinks. However, the National Tiger Estimation Surveys conducted in 2006, 2010, and 2014 have not been consistent with this theory. During the period between 2006 and 2010, the reports indicate the complete opposite, that in India, tigers in poorly protected landscapes with a low density of prey somehow serve as source populations. Then, during the period between 2010 and 2014, this pattern apparently suddenly reverses. Weird. The study also points out glaring gaps in the methodology adopted by these surveys, skipping out on crucial sampling steps and thus giving untrustworthy results. When the researchers conducted experiments involving tiger tracks and scats to assess the population, they arrived at extremely contrasting results. Concerns over the numbers stated in these survey reports are not new, but International Conservation Agency continue to endorse claims of India's success, leading to considerable money being put into tiger conservation budget and probably being misdirected. Wildlife conservation needs to be based on science, not politics, and greater transparency in survey reports and methods are required. Thank you for listening to this episode of Research Matters Podcast. See you next weekend. To hear more such podcasts and news, please log on to www.researchmatters.in.